Advanced glycation end products are a mechanism of aging caused by sugars and other reactive compounds. And what we're going to talk about today is what are they and how do they work. Advanced glycation end products are the result when sugar undergoes certain types of unintended side reactions called non-enzymatic glycations. And to understand the significance of this, it's easiest to use an example. Sugar is the main fuel for the body, and it's a great fuel because it's very reactive. Think of gasoline. Gasoline is a great fuel because it's very reactive. But where do we want these reactions taking place? Do we want them just happening anywhere? No, we only want them happening in certain places at certain times. So with gasoline, we want this reaction to take place in the engine. So to make sure that this reaction takes place at the right place, at the right time, we use an igniter. An igniter is a catalyst for the reaction of gasoline. And basically, the igniter is to gasoline what enzymes are to glucose. The enzymes make sure that the glucose reactions take place at the right place, at the right time. So what happens when these reactions don't take place in the right place? Bad things, right? What happens if gasoline does not react in the right place at the right time? Very bad things. And this is the premise for advanced glycation end products. That is what non-enzymatic glycation is. An enzyme is the trigger. It is the happening without the catalyst. I think an even easier example to understand would be a gun. So we have a gun. It has reactive compounds, gunpowder, and it has a trigger for those reactions to take place. The trigger, right? So what a non-enzymatic glycation is glycation is a type of sugar reaction. Non-enzymatic means without an enzyme. So happening in the right, not in the right place at the right time, right? So a gun, you can pull the trigger and you can trigger the reaction. So a non-enzymatic glycation of a gun would be like the gun going off without you pulling the trigger. That's a non-enzymatic glycation, and quite often it's not going to end very well. So why are these non-enzymatic glycations bad, these uncontrolled reactions? Well, besides there being, obviously, if something uncontrolled is happening, nothing really good can come of it. But more specifically, these uncontrolled reactions are bad because they formed what are known as advanced glycation end products. So reactions take place so that chemicals can become more stable. Sugar is a good fuel because it's very reactive, but it's also relatively unstable compared to other ways it could be formed. So it tries to achieve those things, right? So what ends up happening is that sugar ends up bonding to different proteins in many different ways, but one of the results is a stable end product called an advanced glycation end product, and often it ends up forming a cross-link. So what will happen is you'll have two proteins that will be shackled together, and it makes them less efficient. And this is something that can be easier understood on a larger scale first than making it small. So an example might be, let's say, a car. So you've got an exhaust pipe, and for many cells there are all kinds of things going in and out. Let's say the kidney filtration system. You need to have certain pores of certain size so that it can filter out blood. And when you get cross-linkings in front of it, then that causes it to not be able to do its job as well. Or if you were just to take meat, many of the proteins and enzymes have moving parts. So if you take my arm, if all of a sudden there was a cross-link bonding my arm to my side and I wasn't able to use my arm, now I operate less efficiently. I'm not able to do my job correctly. Now returning back to a very small scale, the most common problem triggered by advanced glycation end products due to the process of aging is the stiffening of tissues. For example, skin and the cardiovascular system becomes stiff over time because of these cross-linkings, and it becomes less elastic, which is why over time people's blood pressure increases because it is stiffer. It's less, the arteries and veins are less able to expand to accommodate incoming blood, so the pressure increases. And it's the same thing with skin. Because it stiffens over time, it makes it more prone to wrinkling. And I have here a very good example of that. So here, I have two pieces of bread. One of them is toasted and one is not. And when you toast something, you basically trigger a series of Maillard reactions, and all that is advanced glycation end products. What happens when you toast something is that it causes the sugars to react with the different proteins and things in the bread. And if you notice, an untoasted piece of bread is very malleable, it's flexible, right? something that has a lot of advanced glycation end products, it's stiff. It's hard for it to bend and it cracks easily. And that's basically what happens in the body as it ages, but simply at a slower rate. By increasing the temperature, all I did was just accelerate those reactions. But over time, eventually, people's heart and their skin are going to become like this piece of toast. It's unyielding, unbending. Those aren't the only problems caused by advanced glycation end products. In fact, a lot more is known about this particular mechanism of aging than most of the other ones because of diabetes. Diabetes is such a well-studied disease and such a prevalent one that a lot of research goes into it. And basically all of the diabetics' problems are in some way related to advanced glycation end products. Kidney failure, blindness, neurological problems, and of course all of these things do happen in regular people, but they happen more quickly in diabetics because they have higher sugar levels. That's the only reason. And not only that, but also the cardiovascular stiffness, the skin stiffness, that also happens at an accelerated rate in diabetics. They age more quickly because they have higher blood sugar levels. So I hope this was able to give you a very good basic understanding of what advanced glycation end products are and why they're bad. And in the future, we're going to go into more detail on the exact mechanisms of how these things take place and the different treatments that are used to help diabetics, but then also may potentially in the future help people who are non-diabetic as well to remove these cross links. So again, hope you found it helpful, and I'll see you next time.